Hello to you who are interested in learning Python programming language. I am at your service with another educational video of this powerful programming language. Thank you for being with me in this educational series. In this chapter, we want to talk about classes. So far, we have written our code without the need of classes, and we did all the work with functions. There are other ways to organize code. One of the most famous and widely used ways is object orientation. As we said before, you are never forced to program with an object-oriented pattern inside Python. This programming language is very flexible in writing code. You can even not use functions, but you have seen the advantages of functions and how helpful they can be. And now classes are the same. But Python doesn't force you to use any of these. As we have covered the topics related to functions to a good extent, although there are still important topics related to functions that can be addressed, we will postpone them until a more advanced tutorial. For now, we are discussing classes here. After you are aware of all aspects of the Python programming language, we will go back and examine the chapters one by one in a more advanced manner and examine the more important and interesting points. For now, we want to get acquainted with classes and object-oriented programming. We want to have the same approach regarding classes. Maybe with what we have said now, the question will arise, what kind of language is Python? What are the types of languages that we know? Some are procedural. You start a process and program, like the first program we wrote in this tutorial. It means that you are not using a function or a class. For example, you specify a list or variable, you perform an operation on them, and that's how things work. Others are functional. In these languages, you have to work with functions. Some other languages are object-oriented. You have to make things and work with them. The answer is that Python supports programming patterns derived from all three of these approaches. These approaches are popular programming approaches. Python is quite flexible in programming, and you can use any of these as you want and combine them with each other to create a more powerful structure for yourself. But if you come with a programming background where you had to write your program inside classes, for example, a Java language, maybe this feature of Python, which does not obligate functional or object-oriented programming, may seem a little strange to you. You may get worried, You may get worried. But don't let this feature confuse and annoy you. Write the code in whatever pattern you are comfortable with. But keep in mind that you are programming with an approach inside Python, but other programmers may not be programming with the approach you prefer. There are many times when you need to refer to other people's code to do something. So it is necessary to learn all the methods so that you can understand the code of other programmers if necessary. Another question that may arise is whether it is wrong to always start with classes. No, it is not wrong. If you are comfortable, you can start with classes. It depends on you actually. What is a class and what does it do? Using a class allows you to have behavior and state inside an object at the same time. Now, what does this mean? When you hear behavior, think function. Think about function. What was a function? It was a multi-line code that you saved in a corner and gave it a name. This function was doing something. For example, it returns something to you. It was printing something. It was returning something like this. In the language of classes, it can be said that it implemented a behavior. What is the situation? What is actually the state? When you hear state, think about a variable. A variable is where you store values. So in simple language, it can be said that the class packages functions and variables and puts them together. So with these interpretations, the class should be something useful. So far we have been working with functions and variables. It is true that other elements were helpful in this, but our main work was with functions and variables, and now we have these two together in class. In Python, we do the behavior of classes with methods. A method is a name given to functions in classes in object-oriented programming. It means that the methods are the same as the class functions. Attributes are the same as class variables. So in general, if we specify a class, this class has two basic elements. One is methods, which are actually the same functions, and the other is attributes, which are actually the same variables. What is the task of a method? Method implements behavior. So in the method, we have the behavior, and in the attribute we have the state. How should we use this class? Do you remember that in the function chapter we used to call functions to use them? That is, we used to define the functions first and then to use them. We used to write the names of the functions and their arguments. In the discussion of classes, in order to use a class, after creating it, we must create an object from this class. This creation of an object from a class is called the object instantiation. To better understand this word instantiation, look at it like, for example, the word invoke. In fact, it is better to look at this word as a call. Like your functions, here you have to call the class, and for this call you have to create an object from this class. That is, by writing the name of the class, you can cast it into an object. To do this, you write the keyword of the class and then write the name of the class and then put the sign colon, and then write what you want to do in the next line. Like the function template we talked about, this is also a class template. We enter a spider. We can implement this template inside the console actually. Let's do it. Let's write the keyword class. You can see the color change here. Let's name the class, for example, count. Let's put the colon sign. Let's press the enter. You can see the indentation here. Let's write the keyword pass. Okay, let's press the enter button of keyboard 2 times, and you can see that. Now the suite we have in this class is only the word pass. Pass is an empty sentence. It means do nothing. You can pass the word you can write the word pass anywhere in the interpreter, anywhere that the interpreter expects to see code. You cannot leave this section of the suite empty. Let's try it. Let's try, for example, class, for example, A. And if we want to leave here empty, the class will never end. But if we type the keyword pass, it will end. Okay. How can we create an object from a class? We do this with the command. For example, A is an equal sign, and then write the name of the class, put the parentheses, opening and closing the parentheses. Press the enter button. Okay, the equal sign and parentheses are important elements. You probably have a question on your mind right now. You may ask yourself that we used to call the functions in the same way. How to understand that this statement represents the creation of an object from the class or the assignment of the value resulting from calling a function to a variable? The answer is that in normal mode and relying on the principles of Python programming, this cannot be understood. But according to the conventions in the naming of functions and classes, this difference can be understood. We saw that in the naming of functions according to PEP 8, all letters are lowercase and words are separated by using underscores. In the naming of classes, PEP 8 suggests that the first letters of the words should be written in capital letters and the words should not be separated by any character. If you follow this convention, there will be no problem and you will have standard code. When you create an object from a class, these objects share the behaviors coded in the class, that is the same methods with other objects, but this is not the case with the states. That is, each object keeps a copy of its own state. Now, what does this mean? I want this count class to start from 0 and count in increments of 1. This is, I want to have a method inside this class that starts from 0 and increases this count number by 1 unit every time this method is executed. It starts from 0 and increases by 1 unit by default, but it has the ability that I can give it any number instead of these two numbers. We create the C object from the count class. Then we tell the interpreter to show us the result. 0 is shown. Here, 0 is shown. We want to create an increase method. How to call it is similar to accessing functions inside modules. You write the name of the object you created from the class, then you put a dot and write the name of the method. There must be a parenthesis. Here you can see that. Finally, after these 3 lines, when we press C again, we will see output 3. This is the default behavior. Another behavior expected from this class is that we can specify the starting point. Another expected, which is shown here, we specified 1000 instead of 0. Another expected behavior is to specify the increment for this class in addition to the starting point, which is shown here. We specified 50 instead of 1. In addition to this, I want my class to have keyword argument capability. For example, consider 2 parameters, val and incur. Okay. Based on this, I would like to be able to, for example, ask the class to consider, for example, INCR as 200, given that the starting point corresponds to the default value of 0. Now, inside these 4 slides, these 4 slides, this, and this one. We have specified the behavior we expect from the class. Keep repeating to yourself that objects share behaviors but not states, which is written here. You can see the same thing in this example. For example, all of these objects can use the increase method. You can see here. but the states are unique, and each one has finally taken its own value. Here the state is 800, here the state is 1250, here the state is 1004, here the state is 3, and you can see they are individual to states. Look at it this way. Suppose you have a factory that makes things for you. This factory is the same class, and now the products of this factory do common tasks and have common behaviors. For example, consider a car factory. All the cars produced in the factory have a brake pedal, and they stop when this pedal is pressed. Or for example, they all have handles that open the car door if they are pulled. But these cars have their own identification codes, and these codes are unique for each car. To better understand why there are parentheses in front of method names when they are called, consider that this is what you are writing. This is what you are writing. But what does the interpreter understand? Behind the scenes, there is a build section that is performed. This is performed by interpreter. This is what the interpreter perceived and understand. This corresponds to the normal case where the parentheses are empty. If in certain cases this method receives the arguments, we put the arguments in parentheses. Now this question may arise, can we use for example this phrase, this command actually, count.increase, open a parenthesis, put the object f inside the parenthesis and then close the parenthesis, instead of writing this one, f.increase, opening and closing parenthesis. Yes, we can, but no one does that. If you understand this change, you will understand why every method in classes has at least one argument. This f.increase statement is actually this calling style of is just for an extra convenience. Now, what should we call this argument that definitely exists? Here, there must be an argument. Now, what should we call this argument that definitely exists? You can use any name you want, but the consensus of Python programmers is on the word self. That is, in fact, this self is the same object, only the name has changed. You know that this self is the same f, for example, here. You know that Python has these customs. You cannot put this self, but you can also not putting this self. It is possible to not to put this self, this word self. But if you don't put it, your code will not be a standard code, and the readability of your code will decrease. Probably in your mind that the definition of the method was like this. But now you understand that the method must have an argument. So the correct one, the correct format is this one, is the second one, the blue one. So the correct definition is in the form of def, increase, opening parentheses, self, keyword, and closing parentheses. Actually, you should not forget to put the colon sign. Be sure to name this argument self to have a more acceptable code. Note that it is not necessary to specify this self in the call. Why? Because Python does this itself. In this video, I tried to introduce you to the basic concepts of classes and object-oriented programming. From the next video, we will move into the Spider environment and examine the topics in a more objective and practical way. Stay tuned as I share my years of experience in programming in the form of several videos and take advantage of the tips I have received over the years. Have a nice day.